Hey everybody, welcome back to another 6.2 video. I've got our screen up where we kind of left off last time, where we kind of talked about rules for means, rules for standard deviations when you are talking about two random variables at the same time. So just to recap from last time, if you have two means that you are combining, you just add them together. So the mean of, I don't know, assembling a box, right, versus painting the box. If you want the average time of assembling the box and painting the box, right, you're going to add those two things together. Same thing for subtraction. So if you want to subtract, if you want to find the difference, the average distance difference, in assembling the box and painting the box, you would just subtract those means. Pretty straightforward right there. Just one more reminder, your order matters. So if you subtract when you are, subtracting two different variables and you get a negative, remember that we're going to interpret that as like a whole value. We're not going to say, oh, the mean is -5. We're going to interpret that as painting the box or assembling the box takes 5 minutes less than painting the box. Something along those lines. So you're going to drop that negative, give it more of a real world value. If you are going to multiply every single variable by, some constant, then your resulting mean, you're just going to multiply it there. That's part B. And then part C, if each value of a random variable is increased or decreased by some number, then your resulting mean, you're also just going to add that number to it. So test scores are a really easy one. Maybe I'm going to curve it and I'm going to add 2 points to every single score. You know that your average is also going to increase by 2 points as well. Standard deviations, a little trickier, right? Any two independent random variables, if you're putting standard deviations together, you cannot add standard deviations. You have to add their variances. And remember, your relationship between variance and standard deviation is that variance is standard deviation squared. So we've got our little variances right here, right? You're going to put two standard deviations together. So standard deviation of assembling the box versus standard deviation of painting the box. We square those two standard deviations. And then same thing if you are subtracting. However, when you are subtracting, you are still adding those variances. Like you are never, ever, ever going to subtract variances. We don't ever see that. You always add those variances. Now, our rules for multiplying stays the same from previously for the mean. So if you are going to multiply every single value in your data set by some value, you are also going to do that with your standard deviation. So this guy right here. And then, so that stays the same from means. You have to be really careful with part C though. Remember that if you add the same number to every single variable in your data set, all the data is still the same distance away. So that standard deviation will never ever change. So even if I'm adding 2 points to every single score in the data set on, some test or whatever, you don't actually change your standard deviation. They're all still the same distance apart from the mean. So does not change at all. That was a little recap. I should have said at the beginning, if you didn't need the recap, you could have skipped ahead a little bit, but you're here, so you might as well just, good refresher, right? A little 3-minute refresher. So, time required to assemble a specific part on an automobile varies from car to car, but we know that we have a mean of 56 seconds and a standard deviation of 3 seconds. That's going to go with my first thing. So just assembling the part is there. But we also know the time required to paint this part has a mean of 78 seconds and standard deviation of 4 seconds. Assemble and paint. I wonder where I got that from. Anyways, so we want to know, what is this? So you've got 4 parts that we're assembling. And we know that it takes 56 seconds. So a couple ways you could do this, right? You could think about this as like, you are doing one part and one part and one part and one part. And so like your mean for assembling, right? Assembling is going to be your first variable that you're looking at, is going to be, 56. There's one part. 56, there's another part, right? We know this. And we could do this 4 times. Or we could, shortcut it and understand okay, I know that this is just 56 4 times, so you could do 56 seconds the mean times how many parts that you're assembling, okay? And that's going to give us 224 seconds for that mean. Now, standard deviation, we got to do a little bit more heavy lifting here. So standard deviation, right, you can't add standard deviation. So you can't just go, okay, I'm going to do my standard deviation, which is 3 seconds, 4 times, and call it a day. You have to add the variances. You have to turn it into a variance first. So if I'm going to do the standard deviation of assembling, okay, I know I have to turn it into a variance first. So turning into a variance, I'm just going to take it and square it. So 3 seconds, I'm going to square that. So 3 squared. Okay, pretty easy. We know how to do that. However, we are doing 4 different parts, so you have to add 4 different variances. So there's 1 part, 2 parts, 3 parts, and 4 parts. Okay. Now, I know that you're looking at that and you're going, I know 3 squared is 9. That's really great. I know that you could totally multiply that by 4. That's really great. It's our first time, so we're gonna have the training wheels on right now, and that's totally okay. Now, to get your standard deviation, though, at the very end, you are going to need to square root all of these guys. So everybody goes in a square root. Okay. Again, I already talked about 3 squared. We know 3 squared is 9. So you have 9 4 times. That's going to be 36. And we know square root of 36 is 6. Okay. So we've got our first piece. We know that to assemble 4 parts, we have a mean of 224 seconds and a standard deviation of 6 seconds. So I'm going to somewhere write a little sentence, maybe right here. Sorry, not neat, but whatever. That's okay. So to assemble 4 parts, the mean of 224 seconds and standard deviation of 6 seconds. Cool. Now, B says, what's the mean and standard deviation to paint 4 parts? So same exact process as the last one. So if you want to skip ahead on this and then just check your answer, you definitely can. I'm going to walk us through it one more time. I'm going to kind of use some more shortcuts. So I'm going to use that multiplying by 4 situation. So if you want to, take it one more step, that's totally fine. If you need to pause and set it up where you write out everything, that's also fine as well. So still 4 parts. Our old mean for this, right, was 78 seconds. And our old standard deviation for this was 4 seconds. Okay, so to find 4 parts, once again, you are going to take that old mean, you are going to multiply it by 4. So 4 times 78, because you are painting 4 parts. So your new mean to paint 4 parts is going to be 312 seconds. Okay. Also, just to refresh, remember that your first variable, I'm just noting it, right, as mu of x, this little x right here. And then your second variable, I'm noting that as mu of y, my other variable. So it's just x, y, first variable, second variable. Okay. Standard deviation is a little trickier. So we are going to go ahead and do that, the variances. So remember, standard deviation of your second variable, right? We are going to take our standard deviation, turn it into a variance. So my standard deviation is 4. We are going to turn that into a variance of 4 squared. Okay. Now, I know there's 4 of them, right? We kind of wrote it out in the first problem where we did 3 squared, 3 squared, 3 squared. If you need to do that, that is totally fine. Otherwise, what you can do is you can say, okay, I'm going to do 4 squared, right? Do some order of operations, some PEMDAS, some algebra. We love to see it. And I'm going to multiply it by 4. When I'm all done, I'm going to square root it. Okay. If you know that shortcut, if you got to write it all out, that is also totally okay. So standard deviation, right now, we've got 4 times 4 squared. Well, 4 squared is 16. And then 4 times 16, that is 64. So I have square root 64 right now, which is just 8. Okay, a little bit cleaner than my last one. And I'm going to go ahead and write a sentence real quick. So looks like to paint 4 parts, sorry. The mean is, wow, I need to do some better wording right here. Sorry about it. Okay, here we go. To paint 4 parts, the mean is 312 seconds. And the standard deviation is 8 seconds. Perfect. Okay. So A and B have been helping us to, get to part C, because now part C is asking us what is the mean and standard deviation to both paint and assemble 4 parts. So we've already done all the heavy lifting. Now what we're going to do is we're going to combine, the values that we got in part A with the values that we got in part B. So if you need a little reminder, or also, these are your notes. So if you want to be like extra specific, so later and you do not have to watch this video all the way over again, we're going to be really particular with our labeling. So remember that mean to assemble. And you know what? If you want to write assemble out instead of writing X out, that is totally okay too. It's your notes, it's whatever. So I'm showing you that I've done that before, right? Mean of assembling, we just found that, right? That was 224 seconds from part A. Mean to paint, that is what we found in part B. That was 312 seconds. Okay. If you remember from the beginning of the video or from the very end of our video from last time, that, to combine 2 means, to do 2 different tasks, all you got to do is add them. So pretty straightforward here. So mean to assemble plus mean to paint is just going to be 224 plus 312. And that's going to give us 536 seconds to do both things. Now your standard deviations, honestly not awful, but a little bit more, a little bit more work. So again, from part A, we had standard deviation, of assemble is 6 seconds, and standard deviation of paint is 8 seconds. Perfect. Okay, so same thing, right? We cannot add standard deviations. We have to add their variances. So we are going to go ahead and say the mean of doing both. Oh man, I just used words and now I'm using variables. You know what? Just roll with it. I'm getting tired of writing. I know you're getting tired of writing. That's okay. So we have to take both of them. We're going to add them together, but we're going to add their variances together. So 6 as a variance is 6 squared. 8 as a variance is 8 squared. And remember to square root everybody at the very end. So 6 squared is 36. 8 squared is 64. So when you combine all these guys, right, you are going to have square root of 100 right now. We love it. That's going to be a really nice number. It's going to be 10. 10, that's 10. Okay. So once again, right, to paint and assemble, four parts. The mean is going to be 536 seconds, and the standard deviation is 10 seconds. Perfect. All right, we're going to do one more in this video because I know videos are hard, right, to watch. I only have the attention span to make one video at a time, so this is going to be our last one, and that's going to wrap up like that third page right there. And then I'll make another video for the rest of 6.2. We're almost done with 6.2. We're going to wrap that up and then get into some really crazy probability stuff. So if there is a 5-second transfer period to get each assembled part to the painting station, we want to now know what is the mean and standard deviation of the time it would take to paint and assemble 4 parts. Okay, so you are not really changing a whole lot here. The only thing that is new here is now what you're going to do is you are going to transfer, right, from the assemble area to the painting area. Now we've already figured out how long is it going to take us to paint and assemble these parts. The only thing we really have to account for is that transfer period. So this is one new thing that you're just adding on. Okay. Yeah. So what we're going to do is we are going to add on one more thing, right? So 5 seconds, 5 seconds, 5 seconds. Now I'm hopefully you're catching on to what I'm saying when I'm saying that we're just adding one more thing. If not, it's okay. Don't worry. I'll cue you in at some point. Okay. So if we're adding something in, we are adding on this 5-second transfer for every single part, right? So the mean to paint, assemble, and transfer. That is all kinds of things. Okay, so paint and assemble, we already found that right above. It is this guy, the 536. That has not changed. This is still how long it's going to take us to paint and assemble 4 parts. But we're adding on that 5-second transfer period. So to every single, part that I paint and assemble, I'm adding this on. So right now I'm only doing 4 parts. So I'm going to do 4 times the 5 seconds, the 4 parts times the 5 seconds. We know that that's 20, right? So 536 plus 20. So our mean is going to change to 556 seconds. Awesome. Now, again, maybe you caught on in that last process when I was really talking it up, but we are not changing a whole lot. We're just adding 5 seconds to every single part that we are assembling and painting. So since every single part is getting this, this 5 seconds added to it, our standard deviation is not going to change. Every single, part is still going to be 10 seconds vary by 10 seconds from the mean. That's our standard deviation. So standard deviation is not going to change because you added 5 seconds to each part. So if you need to write that down as a reminder to you, do that right now. If you don't, you can skip ahead. You can see my sentence. You can call it a day. You could even stop the video right now if you don't want to write that sentence. So no problem there. So since we add 5 seconds to each part, the standard deviation won't change. All right, so last sentence of the video. Okay, the mean time it would take to paint, assemble, and transfer the parts is 556 seconds. And the standard deviation remains the same at 10 seconds. Awesome. Okay, great. So thanks for listening. We are getting to some kind of different stuff in this next one. But that was kind of our intro to combining 2 random variables, even though we did a little bit of it, the previous day with the sweet minivan. But yeah, thank you for watching and have a fantastic day.